So good evening guys, my name is Bhavya Parekh and today we will be making our smart healthcare system using MicroPython, and the mentor of this project is Sachin Patel sir. So what is MicroPython first of all? So MicroPython is basically a programming language based on Python 3, and it is for the microcontroller. So for microcontrollers we generally use the C++ and the Arduino IDE, but this time we will be using the MicroPython, and we will be coding it for the ESP8266 module. So for downloading MicroPython, we first need to go to our command prompt and just type the command pip install esp tool. So it will get installed. I already have it so on my PC, so it is showing that requirement already satisfied. So now let's jump on to our project, and what will be the requirements of this project. So basically we will need a Node MCU with an ESP8266 chip on it, then pulse sensor, then some male to female uh, jumper wires, a temperature sensor, LM35, a breadboard, some more jumper wires, and a USB to micro USB cable. So for this Node MCU, we need to first delete the previous firmware on this board. So for that, we need to connect the Node MCU to our PC, and then we have to go to device manager and check in the port section, which is our COM port. So here we have COM7 right now, and if you are not getting this, you can go to Google and search for CH340G driver for Windows 10, and the first website will be there. Here you will get the CH340 driver for Windows 10. You need to install it, and then you can find the port in the device section. Okay, and then we need to for burning the firmware, we need to install the UPyCraft IDE. So for that you need to go to the UPyCraft IDE install website and install it. Currently I have already downloaded it on my device, so I will be not downloading it again, and we will be going on the UPyCraft IDE. Okay, so here we will select the tool serial COM7, and you can see easily the board selected will be ESP8266. Then we need to burn the firmware and install the new firmware. So for that, here we will be selecting the our board ESP8266 and erase flash. Then we need to confirm our COM7, and we need to install the new firmware. So for that, we will again go to Google and search for micropython.org. Here you can find the Node MCU ESP8266. Then down here there are three chips with 1 MB flash, 2 MB flash, 512 KB flash. So we will be continuing with 1 MB flash and download the bin file given here. Then once it gets downloaded, we will be going on our UPyCraft IDE. Okay, so on the UPyCraft IDE, we need to go to tools, select our COM7, then board ESP8266, and burn firmware. Here we need to select ESP8266 and select to users. We need to add the file which we have downloaded, the bin file which we have downloaded. So we will give the path to it. Okay, so we'll click on OK. Then the flash will be erased and new firmware will be installed on our Node MCU ESP8266. So as you can see, our firmware is installed. Now we can close the IDE, and now we will run our code in VS Code. So for that we need to find the extension called PyMaker, and you have to download both of them. I have already downloaded it, so you can see here that we have our PyMaker icon here. Click on that. Okay, so now after installing our firmware and PyMaker extension on VS Code, we need to create a new project. So we have to go to a folder and click on Control Shift P. So you can see that create a new project here is there. Click on that and you can easily create a new project. I have already created one. So in that blank project you will get a boot file for booting our node MCU, our main.py file where all the code will be there. Okay, so and we need to go to the PyMaker icon again and connect our device to the port. As you can see, this icon is lightened up, so our device is connected. Now I will explain you the code for the pulse sensor. So now let's move on to our circuit connection. So in this uh, pulse sensor, we have the first pin, that is ground. Second is the power source, that will be a 3 volt, and third will be a analog to digital converter, that is A0 pin. So we will connect it using the jumper wires. Okay, so we will be connecting our first pin, that is ground. Here you can see that the first pin is the 3 volt supply, second pin is the ground. So we will be connecting ground to the second pin of the node MCU. Then the second pin of the pulse converter, that is this one, the black wire, is the power source. So we will be connecting it to a 3 volt supply, that is the first pin. And this yellow wire is the ADC, that is the analog to digital converter. We will be connecting it to A0 pin, that is the first pin on the left hand side. So we will be connecting it. Now our circuit connection is done. You can see this green light lightening up on the pulse sensor. So now we will be moving on to the code part. As we have created a new project in the main.py file, we will be continuing our code. So for that, first we need to import the library, that is the machine library, which is used for the MicroPython specially. And from machine we have to import the pin, that is which pins we have used, the signal. One more library from machine, ADC, that is the analog to digital converter, and timer for calculating the time intervals. Now here we are initializing a variable ADC to the analog pin 0 which we have connected. Then LED, which is by default on pin 2, the blue light which will be blinking on that, it is basically not lightened up when the new firmware is installed. So we need to invert that, and we will be inverting it to true, so it will be lightening up all the time. Now we have initialized a variable max history with a value of 250. Now again we have a history which has a blank list, in which we will be storing our readings from the pulse sensor. Then a variable which is a boolean variable beat, and initially its value is false, and the number of bits which will be outputting is equal to 0 initially. Now for calculating the BPM, we have declared a function. We have defined a function in which we have declared beats as global, as we are using beats again and again in the function. So we are globalizing the bits variable, then printing the BPM, and here we need to get the BPM, that is beats per minute. So we will be multiplying it by 6, as we will be getting the readings every 10 seconds. So we will be multiplying the bits by 6. Again we will be initializing bits to 0, which I will explain later in this video. Then timer is equals to timer of 1 for calculating the time interval. Here we are initializing the timer to a period of 10,000 milliseconds, that is 10 seconds we will be getting our output. Then the mode is equals to timer dot periodic, every periodic interval. Then here we are getting a property called callback from the timer library. So we will be calling our calculate BPM function again and again for printing the beats per minute. Here we have declared a variable j, whose value is 0, and we will be printing this BPM only 10 times. So for that we have declared a while loop in which j will be incremented. Now we need to read the readings from the pulse sensor. So for that we have initialized a variable called b, which will be reading the pulse sensor readings through adc.read command, and the readings will be stored in the variable v. Now here interestingly, the pulse sensor will give the readings from 0 to 1023, and the random value will be printed. So we need to convert it into a proper range of 26 bpm normal human bpm to 220 bpm. So for getting the random value in that range, we need to append it in a list. Then here I have taken a for loop in which 500 values will be taken, because only one value cannot be used for calculating a BPM of a person. So we have taken a set of 500 values from which only 250 values will be selected. First 250 values, as we have here selected the max history is equals to 250, which will be here history is equals to history of minus of max history, that and column. So it will select the first 250 readings from the 500 readings, and from that we will be getting the maximum and minimum value. There will be 250 values, and we will be selecting the maximum and minimum from that 250 values. Okay, so why we have taken the minimum and maximum value from this 250 value is because if we have seen a graph, then if we plot these 250 values, then there will be one maximum value which will be the crest of the graph, and one minimum value which will be the top of the graph. So from that graph will be a heart rate graph, which we have seen on the hospital machine. Then we will be taking away two variables, threshold on and threshold off. Now why we are taking this variable? Because between 2 points of a graph, that is the maximum and minimum, there will be several values. So we cannot determine which will be the accurate one. So for determining the accurate value, we will be declaring a threshold and check the value which we have got from the pulse rate sensor, that check the value with that threshold point, and if the value is greater than the threshold point, then the beat will be considered, and if the value is less than a particular threshold point, then the beat will not be considered. So here we will be calculating the threshold point for which the beat will be considered, and for calculating that we have a formula, that is minima, that is the minimum point plus the maximum point into 3, and floor division by 4. So this will give us a value between 0 to 1023 again, and we will be checking if the value we have got, that is the V value, is greater than the threshold point or not. If that value is greater than the threshold point, and if it is not a bit, then it will be considered a bit, and the boolean variable which we have declared as false will be converted to true, and the bit will be considered. And also the bits there will be several values between the maxima and the minima point. So the bits will be calculated accordingly, and also the bits variable will be incremented for that particular point. So there will be many points, and uh, if the value is greater than the threshold point, then the bits will be incremented again and again, and if not, then the bit will not be considered. And if the bit is considered, the LED will blink, so it will get a blue light on it, and if the bit is not considered, it will not blink. And this will happen for 10 times, as we have considered the loop for 10 iterations. So the j value will be incremented, and again this whole process will be considered. Then after this j value is incremented, here it will again go to the function we have defined for calculating the bpm, and here it will see that how many bits we have got from here, that is bits plus is equals to 1, and it will multiply it by 6, so that we can get how many bits are there per minute, as we have considered a time interval of 10 seconds. Therefore again we will be printing our bpm in our terminal, and again initialize this bits is equals to 0. I have previously told that I will explain you later in this video, which I am explaining here, that bits will be again initialized to 0, and a whole new process will start with iteration number 2. So again and again this process will be considered 10 times, and we will be getting our values in the terminal. Now let's see the output of this program. So here we will be clicking on the three dots and stop the script first of all, then upload the script to the device and press the reset button, and now we can put our finger on the pulse sensor, and we can see that the blue light is blinking. Along with that, on the terminal we are also getting the bpm, that is 84, which is normal. Normal range is between 26 bpm to 220 bpm, and for normal breathing, 80 to 100 is the normal range, 60 to 80. So here the loop will execute 10 times, so we will be getting the 10 values. As you can see, the 4 values are normal. So we got our 10 values, and now the process will stop. So this is how the pulse rate sensor works. Now we will be continuing with the temperature sensor. As I don't have the potentiometer, we will not be doing the pulse rate and temperature sensor on the same time, so we will be doing one by one. We have completed our pulse rate sensor part. Now we will be continuing with the temperature sensor, that is we will be using LM35. So let's start with the circuit connection of LM35 temperature sensor. So we will use the breadboard, and this is the LM35 sensor, and we will put it on the first pin of this sensor will be the power pin, second pin will be the output, that is A0, and third pin will be the ground pin. So we will connect that accordingly. So this is our circuit connection. The red wire is the ground wire. We have connected it to the negative terminal of the breadboard, and the negative terminal of the breadboard is connected to the ground pin of the LM35. Then the blue wire is the power source. The positive terminal of the breadboard is connected to the blue wire of positive terminal of the LM35 sensor, and the yellow pin is the analog A0 pin. So we will be continuing with the code part. First of all, I will be commenting this pulse rate out, and we will be bringing in the temperature sensor code. So let's move to the code part of the temperature sensor. Here, as by default, we have to import the machine library, and from machine library we have to import the ADC for the analog to digital converter, and we have initialized it to A0. Then we have initialized a for loop with 10 iterations. That is, it will be giving us the 10 values of the temperature sensor. Now we have defined a function called temp of value, which returns the value divided by 10. Again, we have defined a function called Fahrenheit, and it will be converting the Celsius temperature into Fahrenheit. The math formula for it is Celsius into 9 by 5 plus 32. Now, reading is a variable initialized to ADC dot read. That is, the value from the temperature sensor will be stored in the reading variable. Then the Celsius temp is a variable which calls the function temp of reading, which means that the temperature which we have recorded will be in Celsius when passed through the temp of value function. Then if we want to the Celsius temperature in Fahrenheit, then we will be calling it for the Fahrenheit underscore temp variable. So it Fahrenheit underscore temp variable is initialize the function Fahrenheit of Celsius temp, and we will be printing the all the readings using the format string method. So let's see the output of this program. So here we will upload the program to our device and press the reset button. So here in the terminal you can see the temperature readings are given 12.12 degrees Celsius, and in Fahrenheit it is 53. The initial reading was 122. So as per the temperature reading, there are 10 iterations for the loop, and we are getting the 10 values in normal reading, Celsius reading, and Fahrenheit reading. So this was my project on smart healthcare monitoring system using a pulse sensor and a temperature sensor. If you guys want a source code of this, it is given in the description below. Thank you guys for watching this video, and remember, always be a learner.